Hello and welcome. This is Bijan Hushiar. As far as routers are concerned, they can only reach the networks that are directly attached to them unless we configure routing uh, on them. Routing can be configured either using manual routes or routing dynamic routing protocols such as RIP version 2, EIGRP, OSPF. In here, we are going to assume that router 4 and networks beyond it do not belong to us. They belong to another organization. That organization has already configured R4 with a default static route to reach networks such as this one, and that one through router 3. We are going to therefore configure router 3 with a default route to reach networks like this through router 4. Let's do that first. Enable conft IP route any network with any subnet mask. Send the packet out of my serial 000. I perform show IP route. You'll notice that a default static route that I just created, a route is added, and there are two connected networks to router 3. But router 3 is not aware of this network and this network. Router 4, although it is not ours, but I can pretend that I have access to it and perform show IP route on it. You'll notice that it has two connected networks and one static route for reaching networks such as this, and that through router 3. We want to configure this internetwork with OSPF, single area OSPF. We want to make router 3 the designated router. Therefore, we need to provide that either with highest priority or highest router ID. The priorities of routers by default is 1. It can be changed from 0 to 255. The higher the priority, that router becomes DR. Second highest will become BDR. By default, all the priorities are 1, and we are going to keep it as such. Although we can change it with the interface command of the IP OSPF priority and then a high number such as 255, 254 to force that router become DR. But we keep them as default value. The second criteria for DR BDR election is highest router ID. Highest router ID is an IPv4 address. It could be configured using router ID command. If we do not do that, the highest loopback IPv4 address that we configure on router will become its router ID. If we do not do that, Then the highest IPv4 address that we configure on that router will become its router ID. The router with the highest router ID will become DR, second highest will become BDR. Sometimes a router with lower priority or a lower router ID boots first and become DR. It will stay DR even if a router with a higher priority or higher ID is added to the network. And it is possible for that to happen in this activity too. In order for us to make sure the one that we want is the DR, we need to clear the OSPF process and force election after OSPF is configured and routers are booted. That way, the one that we want will become DR and the one that we want will become BDR. Let's go ahead and do this starting with router 3. Go to router 3 global configuration mode and configure OSPF with this command router OSPF and then a number. That number is the process ID for the OSPF or the instance of OSPF on this router. Then I have to add the networks that this router can advertise through OSPF. I want to make router 3 only advertise this network. That network should be reached through default route. So network 10.10.10.128 with the wildcard mask of 0.0.0.7, which means if a packet is received with the first 29 bits that are matching the first 29 bits of this network address, can be forwarded by this router. The last 3 bits can be anything, it can ignore it. Then after that, I have to put a keyword area and area 0. Area 0 is the backbone area. The first area that we create is that one. Since we are using a single area OSPF, all areas that we use in this activity would be area 0. Now, remember that I created a default route on this router to reach networks beyond router 2. I want OSPF to distribute that to router 1 and router 2. So the command is default dash originate. I'm sorry, default information origin. Information space originate. This command is going to distribute the default route that I created a few moments ago on this router. Then I want to assign a highest router ID to this one as compared to router 1 and router 2. The command is router-id 3.3.3.3. It says that reload or clear IP OSPF process command in order for this to take effect. Otherwise, it may not take effect. We'll see. And the configuration on router 3 is done. I'm going to configure router 1. I go to router 1, I go to privilege mode. First, I show IP route, show IP route to display the routing table of this router to verify that there are only 2 connected networks to this router. It cannot reach any other network unless we configure routing on it. So I go to global configuration mode, conf T, and I configure OSPF with this command router OSPF. The instance that we used on the other router was OSPF10. I'm going to be using the same thing in here, OSPF10. Then I'm going to add the networks that are to be advertised by this instance of OSPF by router 1. Those two networks are this one and this one. So I need two network commands. Network 192.168 192.168.1.0. I want the packets that are received and have exactly the same first three octet to be forwarded by this one. Therefore, the wildcard mask would be 0.0.0, matching the first three octet, ignoring the value for the last octet, keyboard area 0. Enter. Before adding the other network command, I prefer to give it a router ID with this command, router dash ID space 1.1.1.1. Notice that it is the lower router ID than router 3. I'm prompted for the same thing. I have to clear OSPF process. We'll take care of that. Now I want to add the second network that is attached to this one, network 10.10.10.128 with the wildcard mask of 0.0.0.7 keyword area 0. This one is done, and I'm going to configure router 2 enable. Let me show the routing table of it. It has only two connected networks. I'll go to global configuration mode, configure OSPF process ID 10, network 192.168.2.0 0.0.0.255 area 0. I'm going to give it the router ID of 2. Router ID space 2.2.2.2. Hopefully this will become the BDR with this router ID. And then I'm going to add the second network 10.10.10.128 with the wildcard mask of 0.0.0.7 keyboard area 0. This one is done, and okay. Now let's check the routing tables. Now that we have configured OSPF, we'll go to router 3, show IP route. See that? 2 OSPF routes are added. It has learned a path to network 1. It has learned a path to network 2 using OSPF. That O means OSPF. All of them are explained on top. Let me perform another command, show IP protocols. It says that this router is participating in OSPF process ID 10. Router ID is 11.11.11.0. It doesn't say 3.3.3.3. because we need to clear the OSPF process, and that command is from privilege mode clear IP OSPF process. Yes, let's wait for adjacencies to be formed. Let's see if still election is going on. Let's give it a moment, and then show IP OSPF protocols. Show IP protocols. There you go. It is participating in OSPF process ID 10. Router ID is 333. The designated router is this router right now. Let's see if we can verify that. Show IP OSPF neighbor. It says 192.168.1.254 is BDR. 192.168.2.254 is DR other. We want this one to be BDR. Therefore, we go to router 2 and we are going to clear IPOSPF process. Yes. We'll wait for adjacencies to be completed. While we are at it, let's do it on this one too. Clear IPOSPF process. Yes. All right. Let's go back to router 3, see if anything changed over there. Oh, seems to me that it is okay. The router ID, the lowest one is DR other, the second highest is BDR. Therefore, most probably, this particular router that we are on, R3, is DR. Show IP protocols. There you go. It's participating in this process ID. The router ID of it is this one. And let's perform the same command and show IP OSPF neighbor. DR is the one with router ID of 3.3.3, the one that we want it to be. BDR is the one with the router ID of 2.2.2.2, the one that we want it to be, BDR. Router 1 is DR other, meaning it is neither DR nor BDR. As far as the interface priorities are concerned, let me show you the command for that. T interface G00. I can change the priority of this interface with this command. IP OSPF priority Then after that, I have to put a number between 0 to 255. Currently, it is 1. How do I know it is 1? It displays in here under PRI means priority. But I'm not going to change it. I'm going to show you what the rest would be. The rest would be putting a number and then pressing enter. Now that we have configured OSPF single area, let's go ahead and test end-to-end connectivity. The IP address of PC2 is 192.168.2.2. We are going to see if we can ping it from PC1. Ping 192.168.2.2. See if we receive any replies back. Yes, there is connectivity. Now let's go to PC2, and from PC2 try to access the website on this web server. Let's see what the IP address of the web server is, 12.12.12.12. Go to PC2, we go to the web browser. And we type that IP address 12.12.12.12. Go. Let's see if we can ping it. Yes, we can ping it. Should be able to access the web server as well. Twelve. There you go. That's the web page on that web server. We check the routing table of this router. Show IP route. You'll notice that we have received a default route distributed by router 3 to both router 1 and router 2. We didn't create any default route on router 2 and router. That's why PC2 can reach the web server. Let's perform show IP protocol on this one, just in case. Yes, it is part of this OSPF instance. These are the attached network to it. It can reach other networks using OSPF. Let's perform show IP OSPF neighbor. Router 3 with the router ID of 3.3.3.3 is DR. Router 1 with the router ID of the 1.1.1.1, which is the lowest one, is DR other. It is not even BDR. Router 2 is BDR, which is the way that we wanted it. That's how you configure OSPF and perform show commands and test the end-to-end connectivity, making sure it works.
Thank you for watching. If you liked the video and you found it informative, please don't forget to recommend it to others who may be interested. Thank you.